Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the idea of set symmetric difference. And since you have seen the idea of set difference in the previous video, you should be able to find it pretty much easy to follow when it comes to talking about the set symmetric difference. Yeah, right. So simply said, we can define symmetric difference of two sets as something that is related to finding the elements which are in either of the sets but not in the intersection. This is a very loose definition, but if I can perhaps represent it in terms of mathematical notation, basically, when you have the symmetric difference, set symmetric difference, for example, this one here, this is the notation for symmetric difference, or this one doesn't really matter. Now, the idea of symmetric difference is very simple, really. It is about having the union of set difference between A and B and B and A. So that's the idea of this symbol given here. The symmetric difference is about finding the elements that are in either of the sets but not in the intersection, and it can be mathematically represented by this process here. So first you find all the elements that are in this set difference, and then you find the elements that are in this set difference, and you apply the union process. So you consider the elements for both. Okay, right. Now let us try and play around with some sketching or shading. Here we have set A and B, and we're going to try to draw the area that represents the symmetric difference of A and B. Okay, now first, again, like I said earlier, the difference between the symmetric difference between A and B can be represented by this process: A and B, the set difference with A and B, and union with B and A. So that's the idea. So first, if you want to sketch the diagram, we're going to focus on finding what is the area given by this part first. And we know from the previous video, I have demonstrated to you guys that the area for set difference A and B is going to be just on this side. This is the area for set difference A and B. Now, if we consider the next part here, which is finding the area for set difference B and A, we know that the area here is going to be on this side. And again, this is something that I have already explained in the previous video. Now, what we have over here is the union process. So we know that when you're talking about the union of two sets, then you are considering both area at the same time. So you're considering both area. So the final area for this process is going to be given by both area here. So the first one is this one and this one here. So this is the corresponding area for symmetric difference A and B. Okay, so I'm just making it more clear, I hope. So this is the area. Okay, right. Now let us try and solve a slightly complicated problem where now we have three different sets, and we're going to find the symmetric difference of set A, B, and C. Well, now you can try and try to sketch the area first. You can go on and try to sketch the area on your own first, and let's see whether your area is similar to what I'm going to give it to you in a few minutes. Yeah, so this is the moment where you can pause the video and try to do it on your own, and then once you have managed to draw the area, you can start playing the video again to see whether the area that you got is similar to what I'm going to give to you in a few minutes. Yeah. Okay. Now let's go back to this problem here, where I'm going to perhaps segregate the big problem into smaller problem. So first I'm going to focus on this part here. Okay, I'm going to focus on this part, which is symmetric difference of A and B. And I know that for this one, I need to consider the area of set difference A and B and A. So the process involved here is the union between this set difference and this one. Okay, so let us start by sketching the area of this one, which is given by this. Yeah. Okay. And then I'm going to move on to this one, set difference B and A, which is given by this one. Okay. So there you go. So next, I'm going to call this area here, the blue area, I'm going to call it a different name. I'm going to call it set D. Okay, so this blue area here is going to be called something else. So I'm going to call this blue area here, I'm going to give it a name, for example, set D. I'm going to call it D. So now what I'm going to do is I'm going to focus on having replace this with D. So what I have now is I'm going to focus on this part here now. So we're going to find the symmetric difference between D and C. Yeah. So again, in your mind, you should be thinking about what is the meaning of symmetric difference. Really, it's very simple. It's about finding the area where you have the set difference of D and C, and you're going to find the set difference of C and D. And once you got the result, you're going to apply the union process between these two sets here. Okay, so let us try to find what is the area associated with D and C. Remember what is D? D is the blue area. Okay, so D and C means the area that is just related to D but not in C. So what is the area that is related to D but not in C? Where are the elements that are in set D but not in C? So this is C. So this is your C here. Therefore, the area where you have elements of D but not in C is going to be this area. Do you agree? So this is the area for set D. And you're just going to be up till this point because you cannot go in this part because this is already C area. Okay, so I'm focusing on the blue area and I'm looking at the elements in the blue area that is not in C. So I know that this is the part here, and also this is also the part associated with this one. Okay, right? So this is the purple area. So now let's move on to the next area, which is this one. So now I want to find the area, the elements of set C, and it doesn't contain D in it. Okay, so I'm going to find the area which has elements of C only but not D. So this is the area where you have only elements of set C. Yeah. This one cannot because this one got area of D. So this is the overlapping area. But this one can because this is also C and it doesn't contain the blue line. Blue line is D area. Yeah. So this process here, the set difference of C and D is given by this yellow area. So now for final answer, we are going to combine the process of union. Union means you are going to consider this set, which is given by the purple area, and this set, which is given by the yellow area. You're going to consider them together and going to take them together. So final answer is going to be this area. So final answer is going to be this area, this purple area, this purple area. So this is the final answer. This part is also this one, because this is the yellow area, and this is also this one. Now, so this is the final shading for the area asked by this question here. Okay, so why don't we consider the blue one? Because blue one is not purple and yellow. Blue is the previous one, so here is not the area that we're looking for. Yeah, so again, let me tell you one more time. The final area for this question here is going to be represented by the black shading area. And if you find it still confusing to understand why that is such, please try and rewind this video again, and hopefully by the second time or third time you watch this part, you'll be able to get the idea. Okay, right, now let's move on to the next slide. Okay, so this is what I have already said to you just now, where the process of symmetric difference between A and B is very simple. It's just having the union process of set difference A and B and set difference B and A. And of course, as you have seen in the previous video, this one here can be represented by this intersection of A and B prime, and this one is the intersection of B and A prime. So this is something that you have already seen in the previous video. Okay, so now let's try to do some simple example here. So suppose that we have two sets that are defined as A and B, and the question is asking you to find the symmetric difference of B and A. So when you want to find the symmetric difference of B and A, this is basically related to finding what is set difference of A and B, and then you have the union process of B and A, set difference of B and A. So our first step is probably going to find what is set difference of A and B. So again, when you are looking to find the answer to this, you have to remember that you're looking for the elements that are only in A but not in B. So if you look at the first element in A, which is this one, this cannot be considered because it is also there, right there in B, so no. B, this is B, okay. F cannot, okay, because it's over there. G also cannot because it's over here. H, yes, you can consider H because it is only in A. So for the first one here, the elements for set difference A and B is going to be B and H. Yeah. Now we move on to find the elements in set difference B and A. So B and A, okay, I'm just going to erase this part so that it looks better, more clear to you. So now we're going to focus on finding just the elements in B but not in A. So let's look at the first element in B, which is F. So F cannot because it is also given in A. G cannot, okay. A cannot because it is also in this set. So now we've got K. K is okay. So for this one, the answer is just K. And since you want to find the symmetric difference of B and A, we're going to apply the union process. So this is the union process between these two results here. So the union process is basically taking all elements that are given in these two sets. So the final answer to this one is going to be B, H, and K. So you consider all the elements in these two sets here. Okay, that's all for now. Thank you very much for watching.